Alright everybody, welcome to Video Notes for topic 8.3. Today we're talking about a class of chemicals known as endocrine disruptors, and we're starting out here on page 473. So endocrine disruptors are a broad class of chemicals that interfere with the endocrine or hormonal systems of animals, including humans. So most commonly they act by disrupting the actions of hormones by binding to the cellular receptors that are meant for those hormones and thus blocking the effects of those hormones. So we have an example here of this endocrine disruptor, which you can see has a similar shape to the hormone that your body has produced. It's bound to the cellular receptor that is meant for this hormone, and in effect it blocks the action that this hormone should be having in the body. An example of a specific compound that does this is atrazine. Atrazine is a really widely used herbicide, so it kills plant pests that may drive down crop yields. But the problem is that it runs off from agricultural fields into nearby bodies of water, and what it leads to is the blockage of male amphibians converting estrogen, which their bodies naturally produce, into testosterone, which of course is a vital sex hormone for them. This results in lowered sperm counts in males, and even feminization, which is the development of eggs within the testes of these amphibians, and even the development of ovaries altogether if these atrazine compounds are in high enough concentrations. And you may be thinking, well, okay, this is frogs, what's the big deal? This happens with all sorts of organisms. It can lead to skewed gender ratios, where we have far more females than males in a population. That leads to difficulties reproducing and sustaining the population. And this can also happen in humans. So these effects of endocrine disruptors are pretty universal across most classes of animals. Other effects that are included beyond just endocrine disruption include birth defects, low sperm counts in males, again, gender imbalances in populations, so generally more females than males, developmental disorders that can delay or prevent development. And so again, these are all great examples of things to use in place of harm or messes with or toxic. We want to steer clear of hippy-dippy language like that and instead use specific effects such as birth defects or any of these other things. Now we'll talk about a few more specific examples of endocrine disruptors that are really important to know in apes. So it's worth noting that the source of most endocrine disruptors are things like insecticides or herbicides that are used in agriculture, but also plastics and cosmetics that are used kind of in our everyday lives. So the first one we'll touch on here is atrazine. Again, that's an herbicide linked to feminization and lowered sperm counts in males, and that source would typically be agricultural runoff or contaminated produce that hasn't been washed well enough. So make sure if you're buying non-organic produce, or even if you're buying organic produce, there's often cross-contamination from the wind, so make sure you really wash your raw produce very well. Next we have DDT, and DDT has been linked again to feminization and the thinning of the shells of birds, their eggs. And so this is a problem and almost drove the bald eagle to the point of extinction. It's one of the reasons that we finally chose to actually ban DDT in the United States. And although it's banned in most developed nations, it is still used in developing nations. And because it's so persistent, it lingers in the ecosystem far after it's used. There's still certainly ecosystems in the United States that have traces of DDT in them. And then finally we have phthalates, which are a class of chemicals that are found often in plastic food containers. They were previously found in water bottles and even food wrappers and cosmetics, so things like makeup, soaps, deodorants, things like that. And these are linked to the feminization of males. So these are some kind of must-know apes examples of endocrine disruptors. Next we'll be talking about a couple of heavy metals that are endocrine disruptors as well as having other impacts. So the first one is arsenic. Arsenic's a metal that's naturally occurring in rocks in the ground, and it can be released into groundwater. So one of the main sources is contaminated wells or even just contaminated tap water. Mining can lead to rock breaking down and exposing that arsenic to water, which can make this problem of arsenic contamination worse. And then also products that are used to treat woods in wood production factories are another example of a source of arsenic poisoning. Arsenic contamination has been linked to skin, lung, kidney, and even bladder cancer. It's also an endocrine disruptor, hence why we're talking about it in this video. And if you're interested in removing it from water and being sure that it is not contaminating your water sources, many different types of water filters work to remove arsenic. We're not really going to take this sticky. I'm just going to pan up here for a split second to remind you that lead is a heavy metal. It is considered an endocrine disruptor. We have covered it in quite a bit of depth so far, so I'm not going to spend more time on it, but just be aware it is an endocrine disruptor. It is a heavy metal. And the last heavy metal we'll be talking about here today, also an endocrine disruptor, is mercury. So mercury is a heavy metal that occurs naturally in the ground, and one of the main sources of mercury is coal combustion. Other sources include trash incineration or the burning of medical waste, and then also the heating of limestone for cement production. So when you're combusting all of these different materials that contain mercury, the mercury can become attached to or embedded in the particulate matter that's released from the combustion process. So then these particulates go into the air. The wind can carry them, hundreds of miles downwind of the location where the combustion happened. And then those particulate matter with the mercury attached to them deposit into soil or water or elsewhere. One other prevalent source of mercury contamination is from the wastewater from petroleum drilling. So petroleum wells use tons of water, and oftentimes this water is just disposed of on the land nearby, and that water contains mercury, which can then either run off into nearby surface waters or infiltrate into the groundwater. And then one kind of nuanced point here to know about mercury is that mercury itself, just in its pure elemental form, is not harmful. But in bodies of water, and especially in wetlands where there are bacteria that are able to convert it into methylmercury, there it becomes highly toxic to humans and animals. So it damages the central nervous system, so that's what we have here, NS, so it can cause brain damage and nervous system damage, and then it is an endocrine disruptor as well.